Hi, and a very warm welcome to you all. Today I'd like to talk to you about the combination tracing in module MAXiMA with the help of command TRAC. This new command is available in version 2020 only from SOFiSTiK TEDDY. I'd like to demonstrate to you the capabilities of this command through an example file that I had created in the post-tension concrete bridge training. If you haven't reviewed these free training videos on our official YouTube channel yet, then I highly recommend to watch all of them to learn SOFiSTiK. I will provide a link in the description box below to have access to these videos. Nevertheless, the model file that I am about to present can be downloaded from our official website. If you type in the www.sofistik.com into your address line of your internet browser, you will find yourself on the official website of SOFiSTiK. Then you simply need to navigate to Services, then click on the Training and Project Support and scroll down the page a bit. Because there you need to click on the Watch Training Now button, and you will find yourself on a totally new page about the bridge design training. Then all you need to do is click on this Get the Project Files button, and simply you need to download and store the file in one of your folders of your computer. Of course, to be able to do that, you need to fill out this online form and then click on the Get Your Download button. I have already gone through this procedure, namely I downloaded the file, then I opened the .sofistik file. From it I opened the DWG drawing with the help of the SOFI Plus modeling task. And then finally I let every task to be run from the very beginning of this task tree until the CSM bridge design check print of selected elements task. Finally, with the right mouse click, I have opened the report of this task. In the report browser, for better orientation, I collapsed all the chapters, and now I would like to open and present to you the third chapter, which is called AQB Checkprint ULS Design. So I am about to click on this small arrow next to the bulb icon, and I will select from here the Design for Ultimate Loads chapter, and in it I will select the Combination of Load Cases chapter. On the right hand side of the screen you can see that I am presenting the combination of load cases. For example, the 2100-05 and 2100-06 load cases, which contain the G, P, and C actions with safety factors. And in addition to them, the Y_D action, which is the action generated for the pre-superpositioning, or one can say the actions with the external load cases that are acting on the final cross-section. Below in the table of design forces and moments, we can see that we were investigating the beam in group number 2 with the number of 17 at x0 meter, which has the cross-section 101, and the load cases that are presented in this table are 2100-05 and 2100-06. For the time being, let's have a closer look at the load cases of 2100-05 load case. We will find the G, P, and C actions, or the load cases from these actions, such as the 5000 load cases, and also we will find some 6000 load cases, which are coming from the creep action. And as the very last entry, we can find load case 2141. What if we would like to trace back the content of load case 2141? This is exactly what the trace command is for. To try the command out, we need to go back to SSD and insert a new text task into our task tree. So I'm back again in SSD and I'm going to right click on the CSM Bridge Design Check Print of Selected Elements task and choose the Insert Task option from the drop-down list, and as the very first entry I will find the text editor. I will select it and click on the OK button. I'd like to rename this task, so I'm going to right click on it again and choose the rename option. The new title that I'm going to enter is Trace Back Combinations. And by double clicking on the task, I am going to open it for editing. To save some time, I have already entered the command and its parameters in module MAXiMA. Yes, as you can see, this trace command is only available via text input in module MAXiMA. It is also very important to mention that this command can only be undertaken in a separate new MAXiMA run. This means after you having created the combination rule and you extracted the results with the command superpositioning, then you need to open or create a new MAXiMA run, and in it you have the possibility to trace back the combination. Okay, now let's have a closer look at the command and its parameters via the online help. So I will select the command TRAC and hit the F1 button, and the online help will open for me. The first item or parameter of this command is the LC, so the load case. Basically, the resulting load case number of the previous MAXiMA run needs to be given here. In our example file, this is going to be the 2141 and 2142. Then the second item or parameter of this command TRAC is the E-type, with which we can specify the element type we would like to trace back. This could be the nodes of our system, the beam elements in our system, the design elements in our system, trusses, cables, quad elements in our system. Then in the next item or parameter, which is called element, we need to specify the element number or the node number. In parameter X, we need to specify the location of the extraction or tracing back within the element. With parameter SELE, you can even select a stress point, for example, within the cross section from which you want to trace back the combination. Finally, with the help of the last parameter, which is called opt, the users have two options to trace back the results. These are namely the following. With the option and the value I, one can trace back the intermediate superpositions as well. And with the value F, one can filter out the load cases that do not contribute to this very specific superposition. Let me describe this parameter opt in more detail later on. As you can see, the default value is using the values I and F together. So if I'm not entering anything for parameter opt, the tracing the intermediate superposition and filtering out the load cases will take place. Okay, now let me add the values of the parameters. So the load cases that we would like to trace back are the 2141, and with a comma I can also add the next load case, 2142. For the parameter E-type, I will simply add beam. The number of the elements to trace back will be 200,017 and 200,035 respectively. Now let me close back the online help to have a better overview. And the location where we would like to extract or trace back the combination will be at 0 meters, so I will simply add 0 and a space. Finally, for parameter opt, I would like to use the default values, so I'm just simply going to delete this parameter opt for the time being. To have a better visual about these two chosen elements, I would like to go back to System Visualization and present these two elements to you. Maybe the best way to do that if I'm clicking on the CSM Bridge Design task here 2 times, and the task will be open, and there I'm going to the check print and select this little butterfly icon to select beam elements. If I do so, the 2 already selected beam elements will be highlighted. As you can see in the middle of the first pan, the beam element with number 200,017 is shown. And at the vicinity of the middle support, we will find the beam with element number 200,035. Then I will click with my right mouse button and choose the cancel selection to go back to the dialog box. And here I'm also going to hit the cancel button because I just wanted to show you the selected elements. Okay, now let's go back to the traceback combination task by selecting it. And let us run this task by right-click on it and choose the Calculate Traceback Combinations. As you can see, the task was run through very fast. Let's have a closer look at the results by opening its report. I will right-click on it and choose the reports from the drop-down list. Now let's see how we need to understand or interpret this output. On the left-hand side of my screen, you can see that we are looking at the tracing back of combination rule 21. On the right-hand side, you can see the 2 beams that were traced back, namely 200,017 and 200,035. Let's focus on the first one. What else can we see in the table? We will find the individual load cases that were contributing to this combination rule. First, we can read their numbers. For example, the contributing load cases in this case were load case 52, settlement at the middle pier. Then, from the traffic loader task, load case 110, which was derived for the maximum MY bending moment from the tendon system loads. Load case 210, which was also derived from the traffic loader task and was generated for the maximum MY bending moment from the uniformly distributed loads of the predefined load train. And finally, load case 98, the temperature load, which was set up for the winter case, so for the cooling down. Then in the next column, we can see the contributing factors of these load cases. And from it, we are able to decide which load cases are coming from the leading action. Because, for example, in this case, I can see that load case 110 and 210 will be multiplied with a factor of 1.35 respectively. So these load cases are the leading ones. Or one can say that they are coming from the leading action. And the load cases 52 and 98 with a factor of 1 and 0.9 are coming from the accompanying action. Finally, we can read the overall contribution of load case 2141 in kilonewton meter to the MY bending moment. The way how this 9021.9-ish kilonewton meter is calculated was taking the 353.9 and multiplied by 1, then the 3166.616 multiplied by 1.35, the 2433.14 was multiplied by 1.35, and finally the 1232.9 was multiplied by 0.9, which builds up the overall 9021.86 kilonewton meter. Now let's go back to the check print of the selected element output and see how this roughly 9022 kilonewton meter can be compared to the overall result of load case 2100-05 and 06. So if I'm heading back to the check print of the selected beam elements, in the design forces and moments, we will see the overall bending moment from the load case 2100-05 is 19,387.23 kilonewton meter, from which the load case 2141 gives this roughly 9,000 kilonewton meter. The remaining part is coming from the load cases mentioned in this table, so from the G, P, and C actions. Next, I would like to present how the parameter opt influences the representation of the results. So let's go back to SSD and play a little bit with the parameter opt. Now we're back again in SSD, and as you can see, I use the default value of parameter opt because I haven't entered any value for parameter opt. However, now I'm going to do that and type in opt, and instead of the default value, which is the I and F together, I am just going to use the opt I and see in the report browser how this input affects the representation of the results in the report browser. Before I run the task with the current input, let's go back to the representation of the results, just to remember how it looks like. Now I'm heading back to SSD, run the task to see the differences. I'm right-clicking on the task one more time and select the Calculate Trace Back Combination option, and then I will go back to the report browser and I'm going to be asked if I want the report browser to be reloaded. I will select yes. And by doing so, as you can see, I have many load cases now in my table. Actually, all the load cases that could contribute to the value of 9021.86 kilonewton meter. However, all the load cases that were not selected to be contributing to this 9000 kilonewton meter can be seen with a factor of 0. So if we have a closer look at the temperature load cases, for example, from load case 91 till 98, we will find that module MAXiMA didn't choose the load cases from 91 till 97 because they didn't deliver the most unfavorable effect to this combination. But on the other hand, module MAXiMA chose load case 98 and multiplied with 0.9 to get the 1232 kilonewton meter, which gives the most unfavorable effect to the overall 9021.86 kilonewton meter. So now we can conclude that the parameter opt-F is basically filtering out the load cases that were not selected for the contribution of the maximum or minimum internal force. As you can see, printing the unnecessary or unselected load cases can be very disturbing and cause very long output tables, and therefore the default value is to use opt-F, the filtering option in command TRAC. Now let's go back to SSD and try out the other value of parameter opt which was the value I. So I'm back again to SSD, and now I would like to demonstrate the other value of parameter opt, which is the value I. And to demonstrate it, I will simply copy the first input line with the F8 button, and I will comment out the first command line because I would like to change the input load case in this case. Instead of the given load cases 2141 and 42, I'm going to enter 2121 and 22. For those who haven't reviewed the post-tension concrete beam bridge tutorial yet, I would like to give some more information about these two load cases. And the best way I can do is by opening the input of this CSM bridge design superpositioning task. If I do so, the input will look something like that, and what we are reviewing is the final superpositioning for SLS and ULS, including the GPC actions. If we scroll down a little bit, we are going to find these two load cases, the 2121 and the 2122, which load cases are set up for the maximum and minimum MY bending moment in the beam elements in the ULS state. And the reason why I have chosen these two load cases is that they contain intermediate superpositions. And this is what I would like to demonstrate with the opt-I. So I'm back again to SSD, and I'm going to run the load cases 2121 and 2122 with opt-F. So the I is excluded, and let's see the results in this case. So I will simply right-click on the task and choose the calculate option, and then I'm going to look at the results. And what we are reviewing is at the moment is the output of load case 2121 and 2122. What we can see is that the contributing load cases are 5025, 35, 5020, 30, 21, and then the load case 2141. However, this load case is a result of an intermediate superposition. In other words, it contains other load cases. So what if I would like to see what load cases are contributing to this 9021.86 kilonewton meter? And exactly this is what the option I is controlling. So let's go back to SSD and change the input to opt-IF. So in SSD I will simply add this option I, and I will rerun the task, and let's have a look at the resulting table now. If I am back to the report browser, the software asks me if I want the report to be reloaded. I will choose yes, and as you can see, the previously presented load case 2141 is now unwrapped to load cases 52, 110, 210, and 98. And we can even find their contributing factors to this load case 2141, and finally to the overall result. So to conclude, the parameter opt-I controls whether or not the intermediate superpositions to be unwrapped or to be presented in one single load case. At this instinct, I would like to give you two very important notifications. The first one is that only the combinations that were generated within module MAXiMA can be traced back. It seems to be obvious, but actually you can create combination in module AQB, and those combinations cannot trace back with the command TRAC. Let me demonstrate it with an example. if I change the numbers here to 2100.05 or 06, which load cases were generated in module AQB to get the maximum My and minimum My bending moment for the ULS design, then we can see that if we try to run these load cases, we are simply going to get error messages regarding the load cases not being generated with module MAXiMA. But let's see that. So I'm back again to SSD and I'm going to run once more this task, and as I expected, I have received error messages that no sup record could be found in the database. Of course, this is the case because these two load cases were generated with module AQB, in which this sup command doesn't exist. The other important notification I would like to give you is that if I write back the load cases 2121 and 22 and run module MAXiMA with opt F, excluding the value I, then what we see in the report is that the load case 2141 is not unfolded, but we also see a very important thing here, namely that the designation or the title of this load case is d_temp beam my node tx, which could be a little bit misleading. But if we go into the input, you can see that the storing load case 2121 occurs several times at this superpositioning, and therefore the title will reflect to this, and it's going to show beam my and node px. At this moment, I'd like to call your attention to a third very important notification, namely to use unique numbers for numbering the combination rules. What does it mean exactly? If I now click on the generation of the combination rules here at the MAXiMA final superposition SLS and ULS including GPC, one can see that the combination has a unique number and the next combination has another number. And this is exactly the required type of definition, because if someone doesn't pay much attention to the unique numbering and use the same number 2 or more times, then the command TRAC will not be able to trace back the results of the combination. It might sound obvious, but I oftentimes meet problems from the customers using command TRAC that are originating back to the non-unique numbers of the combinations. So, hence my hint regarding this. If we now go back to SSD, I would like to call your attention one of the limitations of using this command TRAC, and I'm going to show to you via the online help of command TRAC. So I will open the online help with the F1 button, and I will simply scroll down a little bit where we can find this limitation or a hint regarding this limitation, namely, as it is stated, currently it is not possible to trace superpositions associated with result sets, boundary elements, and tendon stress for quad elements, as well as superpositions according to a user-defined function. Apart from this limitation, we are hoping that you are going to enjoy this new feature in version 2020, tracing back the combinations. And by having said that, I would like to thank you for your attention.